Hello, this video is going to show how we can achieve functional safety using Silicon Labs Simplicity Studio. Now, I could have shown this with any ARM device that's supported by Simplicity Studio, but what I've got connected to my laptop at the moment is this Giant Gecko board, and this is a Cortex M3, and it has a J-Link on board. Now, starting point is of course the Simplicity IDE. And inside here, I've created a number of projects, and this is the one that I'm interested in at the moment. Let's take a quick look here at the main, and there's some pretty simple code. And what I'd like to be able to do is first of all take a look at this code and see, well, is it compliant to a coding standard such as MISRA? I'd then like to be able to measure a number of metrics on the code, getting an idea of, well, how complex are these functions? And then I'd like to execute the code on the target, and as it executes, I'd like to find out, well, how much of this code have we actually exercised? I probably won't get 100%, and so then I'll use the unit testing tool tbrun in order to be able to complement that coverage and do some unit testing. Now, let's check first of all we can build this project. So there we can see that's successfully built. And what you'll notice here is I've got a build.bat file that will do exactly the same. So what I'm going to do is I'm going to open up first of all the LDRA launcher, and inside here I'm going to run the build import. And inside the build import I've already configured it to effectively point to the folder where that build.bat is located, and I'm now going to execute the very same build, but this time inside of this build system import. And we've listened to the build, and we've found an executable, and we've found a list of source files, a list of preprocessor symbols, and also a list of the include paths. So now we have everything we need in order to be able to open this project in TV Vision and start to analyze it. Well, to save time, I've already done that, and so now I'm simply going to be able to do a code review. And I can see, well, this code wasn't written to be compliant to MISRA, and so we have quite a few different violations. Well, let's take a look at this one here. Username starts with underscore. Well, if I double click on that, it opens up the editor and takes me to the place where we can see, yes, we have put an underscore in front of that, and that's reserved for the compiler. So that's very easy to fix. Okay, what about the quality of this code? Well, let's take a look at the system call graph. And the system call graph is going to show us all the functions. We can see how they're interconnected, and they're even color coded to show us in green if we have any system calls. And we can put this into various different views. So we can view the testability, looking at things like procedure exit points, fan in, fan out. But what I'm interested in here is the maintainability view, where I can view the cyclomatic complexity, and I've sorted and found the most complex function, that is this integer to ASCII. So let's view this as a flow graph, and that gives us a graphical representation of the code. And if we click on a particular block over here, we can see the corresponding block inside the code. Which block is this one? Well, we can see it points to there. What about this branch here? Well, that's the branch from here down to there. Okay, so now what I'd like to be able to do is to execute this code, and as it executes, find out how much of the code have we actually exercised. So let's go and perform the dynamic analysis. So this is now going to instrument the source code. It's then going to build it, and now it's executing it on the target. So we saw the J-Link that was used to flash the target, and then we're using GDB. We've got the data off the target, we've analyzed it, and let's take a look at the results. So once again, we're going to view the system call graph, and this time we can put it into a view that shows us the coverage. And there we can see the coverage we've obtained. Well, let's take a look at this integer to ASCII and view that graphically. So we have 79% statement coverage, and we can see very clearly we have 1, 2, 3, 4 blocks of code that have not been executed, as well as 3 branches in the code that again have not been executed. So why haven't we executed this? Well, it looks like we've never had a value less than 180. So we can use the unit testing tool tbrun in order to be able to complement this coverage. So let's do that. So I'm going to go and invoke tbrun, and inside tbrun I'm going to open a sequence of test cases that I've previously created. So here, if I go into my test cases, we can find a sequence of test cases for this function integer to ASCII. And here we can see I've got a test case with a value less than 180, so that should exercise that bit of code that we hadn't got coverage for. Over here we're going to be able to see we have a list of the inputs and then the expected outputs. Right, well, let's execute this on the target. So this is now generated a harness, it's built it, it's just flashed it, again using the JLink, and now we're using GDB, we're executing, and we just need to wait a little bit of time for this to execute, and then we'll be able to view the results as well as the extra coverage. Right, so that's executed. We can see the good news is all our tests have passed. So with these inputs, we did get the expected outputs that we can see over here. Right, what about the coverage? Well, let's go and take a look at the integer to ASCII. And now we should be able to see that we have 100% statement coverage, 100% branch decision coverage, and also 100% MCDC. Okay, so hopefully that's given you a quick overview of how we can work with Silicon Labs Simplicity Studio. And if you'd like more information, then please don't hesitate to contact us at LDRA. Thank you.